Unit 10, Exponential Equations. This is your retake review. Just a quick reminder, when you do your retest, it's going to be 10 problems very similar to these, so please make sure that you know how to answer them before you take your actual retest. All right, real quickly, what I would have you guys do is go ahead on your paper and write down these 4 formulas. These 4 formulas will be given to you when you retest. We probably should have typed them on the test, but oh well, they're already printed. So write them down. Here we go. We're going to take a look at first question. Write a rule. Guys, write a rule just means write an equation. Write a rule for the nth term of the geometric sequence, 0.04, 0.32, and so on and so forth. You guys are going to be using this formula to write a rule. And you got a good hint, right, because you've got this a sub n right here in your answer. So let's just figure out what is a sub 1 and what is r, right, because that's all we need to be done with this question. Well, a sub 1 literally means the first term, so 0.04, so that number is going right in the front. And then we got to figure out what r is, and we're going to keep the exponent n minus 1. Now, r means what are we multiplying by to get from one term to the next term? And a real easy way to determine this is to go ahead and divide whatever term you choose, right? I'm choosing this term, divide it by the previous term, so 0.04, and this will give me r. So what is 0.32 divided by 0.4? I think it's 8. Let's check. 0.32 divided by 0.04, and we get 8. So r is 8, and that's my rule. All you had to do was write down the initial amount, figure out the r value, and put it in your formula. Let's look at question 2. Question 2 says, what is the initial amount? Well, the initial amount happens when x is 0. So your answer here is write that first term when x is 0, so your initial amount is 4. Question number 4, I'm going to go ahead and skip 2. You guys see this question right under here? Because it has the same table as question 2, right? Here we were asked for the initial amount. Question 4, we're asking what is the growth or the decay factor of the function shown in the table. This means what are we multiplying by? Right? That's what we've got to figure out. What are we multiplying by? So let's look. How do I get from 4 to 12? Well, it's times 3. How do I get from 12 to 36? Again, times 3, 36 to 108. You guessed it, times 3. So what is my growth factor or my decay factor? Well, it is a growth factor this time because it's bigger than 1, and it is 3. Question number 3, we skipped it. We're coming back to it right now. We're going to write a function, right? Write an equation to represent the relationship in the table. Guys, you got a table. Please make sure you do stat edit. Now, since this test is on exponentials, you're going to choose option 0, which said exp reg, right? Exponential functions. So in our calculator, we're going to go to stat edit, and you can see that I've already typed in the numbers to my table, right? I took these numbers here, this column, the x's, this is L1, the y's are L2. I'm going to go over to stat, and I'm going to choose option 0. All right, option 0 is exponential regression. Just click enter till it gives you your answer. Here we go. So it told me A is 0.6 and it told me B is 5. So that's what I use, right? 0.6 goes in the front, B goes in parentheses to the power of x, right? Because we're using this as our formula, right? That's what it says up top, A times B to the x. So this is how we write it. So for this question, all you got to do is stat edit. Question number 5. Notice we have bolded, write an equation. That's all we're doing for this question. You don't have to answer it. We're just writing an equation. Suppose a radioactive substance loses half of its remaining mass each day. So loses half, that's important. Write an equation that can be used to determine how much of a 58-gram sample will remain after X days. You guys definitely need to know that we're using this formula here, where A is just our initial amount, right? A is our initial amount, don't forget. And B is our growth or our decay factor, right? Growth, decay factor. So my answer for this, right, in this case, my initial amount A is going to be 58 grams, and my growth factor or decay factor is going to be 1/2, right? We're losing 1/2. Do not make this negative. A lot of people screw that up. They make it negative. No, no, just leave it as 1/2. So y equals 58 times 1/2 to the power of x. And that's my answer. Question 6. Patrick bought a car for $38,000. The car is depreciating at a rate of 8% per year. What will be the approximate value of the car after 6 years? So the formula we're going to use here is this one from the top here. We're going to use a minus r to the x. I used a minus because of the word depreciating. Now we can fill in the numbers. We're going to say y equals, a is my initial amount, so in this case that's going to be 38,000. We keep the 1 minus, but r, 8%, is equal to 0.08, right? We move that decimal place 2 times and get 0.08. So 1 minus 0.08 to the power of x. Now in this case, it actually wants us to calculate something. So after 6 years, all we got to do is actually go ahead and plug in a 6 for x, right? 6 years, plug in a 6 for x, 0.08 to the power of 6. And this is going to equal, I don't know, let's use my calculator. We're going to type it in just like we wrote it, 38,000, parentheses, we got 1 minus 0.08 to the power of, so that's this key right up here, the caret key, to the power of 6. Okay, this car is now worth $23,041.49. Round to the nearest cent, right? And that makes sense, right? We started with 38,000, it's a losing value. We ended up with 23,000. That seems like a reasonable answer. Problem 7 should be quick and easy. We're answering all 3 parts. Is this function growth or decay? This function right here is growth, right? Because this number in the parentheses is bigger than 1. So 5 is greater than 1. Right, so we have growth. What is the y-intercept of this function? The y-intercept is simply 1/3. Right, the y-intercept, means your a value. And then finally, what is the growth or decay factor? It's just literally the number in there, so that was 5. Question number 8. An automotive specialist observes the value of a car over time. The table below shows the value after x years. What will the car be worth in 8 years? You need an equation, which means you need to do stat edit, and you've got to choose option 0, right? This is exponential, and we're going to get our equations. We're going to go to stat, we're going to go to edit, and bear with me because I have to fix these numbers here. So we're going to do 0, 1, 2, 3, 4, 5, and 6. And then we're going to go ahead and type in the next number. So 23,022. 16115 11281 7896.50 5527.60, and then we've got 3869.30. And finally, we've got 2708.50. All right, we've got our numbers in. We're going to go back to stat. We're going to go over to calc. We're going to choose option 0 for exponential regression. And we get our equation here. I'm going to write it down. So my calculator is giving me y equals 23,021.92 is what I'll do. And then we're getting 0.7 to the power of x. Okay, this is a really good equation. Notice how close this is to my actual initial amount. That means my regression equation is pretty close to the real thing, to the actual points, which is good. Right? Also, the fact that we've got an r of 0.99 is really good. So if I want to know what will the car be worth in 8 years, we just got to plug in the 8 for x. So we're going to do 23,021.92. Got 7.7 in parentheses to the power of 8, and that is something I just have to calculate. So 23,021.92. We've got 0.7 in the parentheses, and we've got to the power of 8. So in 8 years, my car will be worth, wow, 1,300. Let's see here. Did I write that down correctly? Let me double check. Whoops. Sorry, that seems like a lot of money to lose for a car. Just want to check this value. Yep, 0.7. All right, I got it right. So this car is losing its value fast, right? This car is losing its value really fast. So the answer that we got was, just a second, sorry, 1327.16. I'm going to round up because of that 7 and say 0.17. All right, this car lost its value very, 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 very fast. Problem 9 and 10 are quick. Here we go. The domain of the graph, since it's going left forever and right forever, the domain is all real numbers. The range of the graph is y is greater than 0, right? It doesn't actually touch 0, but it's all in the positives. All right, the fact that it doesn't actually touch 0 is because of this asymptote. You guys remember this word? Means the line is going to get so close to 0, but it's never actually going to touch it because there is an asymptote, and that equation is y equals 0. If you put this little or equal to symbol, you are incorrect. It's not going to touch this line, right? That's the asymptote. Remember, don't touch the asymptote. What is the y-intercept? Guys, please don't get this wrong. Okay, the y-intercept is 3. Does the graph show exponential growth or decay? Well, from left to right, it's decreasing, so we get to say decay. Finally, the last one, which of the following could be the equation of the graph? All you guys need to know is that this number here, the y-intercept, is your a value, right? That's always the number in the front, the y-intercept. So since my y-intercept is 3, this has to be my answer. If you weren't sure or you forget when you take your test, put this in y equals, does it match the graph? Nope, then it's not your answer. Put this in y equals, does it match the graph? It does, then that's your answer. But again, if you can just remember the number in the front is your y-intercept, you should be good to go. Also the fact that it's decay, right? Less than 1. All right, let me remind you, I already said, I'm going to say it again. Make sure you can do all 10 of these questions by yourself before you retest, and good luck.